For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@matlabassignmentexperts.com, info@matlabassignmentexperts.com, or reach us at https://www.matlabassignmentexperts.com. 1. Do the following for a fifth-order Butterworth filter with cutoff frequency of 1 kHz and transfer function Bs. A. Write the expression for the magnitude squared of the frequency response. B. Sketch the locations of the poles of B, S, B, S. C. Indicate the locations of the poles of Bs, assuming that Bs represents a causal and stable filter. D. Indicate the locations of the poles of B, S. 2. Figure P24.2-1 shows the frequency response of a discrete time filter. A. Determine and sketch the analog frequency response characteristic that, assuming no aliasing, will map to the discrete time frequency response given in the figure when the impulse invariance method is used. Problems. MATLABassignmentexperts.com. B. Sketch the analog frequency response that will map to the discrete time frequency response in figure P24.2-1 when the bilinear transformation is applied. C. Repeat parts A and B for the discrete time frequency response characteristic in figure P24.2-2. 3. Consider the system function. A. Determine the discrete time transfer function HD(z) obtained by mapping HCS to HD(z) using the bilinear transformation with t equals 2. B. Find the range of the constant A for which Hs is stable and causal. C. Verify that if Hs is stable and causal, then Hz is also stable and causal. 4. Consider the following discrete time filter specifications. MATLABassignmentexperts.com. To design HD(AJU) using the impulse invariance method or the bilinear transfer MAT-ion, we need first to specify a continuous time filter B, JW. Assume that we will use a Butterworth filter. Set up the proper equations for the order n and the cutoff frequency W of the continuous time filter B, JW, that will map to HD(En) when the impulse invariance method is used. Set t equals 1. B. Set up the proper equations for n and W of B to Jo when the bilinear transfer MAT-ion is used. Set t equals 1. 5. Consider the system in figure P24.5, which implements a continuous time filter by discrete time processing. The sampling frequency is 15 kHz. The continuous time filter must satisfy the following specifications. MATLABassignmentexperts.com. A. Determine the appropriate specifications for HEJ, the frequency response of the discrete time filter. B. Suppose that to design HEJ, we use the impulse invariance method. We need to introduce a second continuous time filter, JW. Using t equals 3 for the value of the parameter t in the impulse invariance design procedure, determine the filter specifications of JW. C. Suppose that we now use the bilinear transformation to design HEJ. Using t equals 2 for the value of the parameter t in the bilinear transformation method, determine the filter specification of JW. D. With either the impulse invariance or bilinear design procedure, is HEJ or HJW dependent in any way on the parameter t? 6. In this problem we consider more closely the design procedure for continuous time Butterworth filters. Suppose that we are to design a filter B, JW, such that MATLABassignmentexperts.com. A. There are two unknown parameters, the order n of Bs and the cutoff frequency co. Set up the two simultaneous equations for n and co, and verify that n equals 5.88 and w equals 7.047 satisfy the equations. B. Since n is not an integer, we must choose n to be the next higher integer. We can now pick whether to meet exactly the stop band specification and exceed the passband specification or vice versa. Find W such that the passband specifica tie-in is met exactly, and verify that the stop band specification is exceeded. C. What would happen if we picked n equals 5? 7. We want to design a discrete time low-pass filter with a passband magnitude characteristic that is constant to within 0.75 dB for frequencies below 0 is equal to 0. 2613x and that has a stop band attenuation of at least 20 dB for frequencies between Q equals 0.4018x and R. Determine the poles of the lowest order Butterworth continuous time transfer function that, when mapped to a discrete time filter using the bilinear transformation with t equals 1, will meet the specifications. If possible, exceed the stop band specifications. Indicate also how you would proceed to obtain the transfer function of the discrete time filter. 8. Suppose that we want to design a discrete time filter using the impulse invariance method. The filter specifications are given by MATLABassignmentexperts.com. Using t equals 3, we obtain the corresponding filter specifications for the associated continuous time filter HBS. Assume that a filter HS satisfies the specifications exactly. Thus, the designed discrete time filter is given by study the case of t equals 2. A. For t equals 2, give the filter specifications for the associated continuous time filter is. B. Verify that the continuous time filter given by MATLABassignmentexperts.com satisfies part A exactly. C. Substitute 11s from part B to solve for H AJA and verify that H EI equals H AJU. Thus, the value of t does not affect the final discrete time filter designed. 9. As mentioned in section 10.8.3 of the text, the bilinear transformation map from the S-plane to the Z-plane can be interpreted as arising from the use of the trapezoidal rule in numerically integrating differential equations. Consider a continuous time system for which the differential equation is. Or, equivalently, determine the system function Hs for this continuous time system. In numerical analysis, the procedure known as the trapezoidal rule for integration proceeds by approximating the continuous time function as a set of contiguous trapezoids, as illustrated in figure P24.9a, and then adding their areas to compute the total integral. The area A of an individual trapezoid, with dimensions shown in figure P24.9b, is MATLABassignmentexperts.com. B. What is the area and in the trapezoidal approximation between x n-1, t, and x and t? C. From EQ, P24.9-2, y nt denotes the area under xt up to time t equals nt. Let y, n denote the approximation to y, nt, obtained using the trapezoidal rule for integration, that is, MATLABassignmentexperts.com. Show that D with v, n, defined as and n equals x and t, show that the trapezoidal